Morning, Nathan. Well, by the time you hear this, it won't really. Well, I guess it'll still technically be morning. It'll be 11:40 something. So I guess that's still technically morning. All right, we're gonna move on with the proofs. So section 2.2's notes. Um, finish up section 2.1, the homework on that first, and then we'll work. Then go straight to the notes. So basically, this section is just a whole lot of reasons that we're going to use during our proof. And we're going to actually learn the names of them and be able to back up everything we say. I know tons of these you already know, so it's going to be really simple. Distributed property. Ah. If A times the quantity B plus C is sitting there, you can make that AB plus AC. Yes, I know you know that. The properties of equality. So there's an addition property of equality, there's a subtraction property of equality, there's a multiplication property of equality, there's a division property of equality. Technically, these two don't have to exist because you could say that subtracting 4, you're adding a negative 4, or dividing by 3 is multiplying by a third. So, but most people like to throw in those two because that's the way they think about it. You'll see what I'm talking about in a second. So the addition property of equality says that if, my pen keeps messing up, okay. If A equals B and C equals D, then A plus C is the same thing as B plus D. Basically, this is just saying if you have an equation, we can add the same amount to both sides and it's still equivalent. Subtraction property, same idea. If A equals B and C equals D, then A minus C is equal to B minus D. In other words, we can subtract the same thing off both sides of an equation, and you still have a true statement. This one, multiplication property, if A is equal to B, then C times A is the same thing as C times B. We can multiply both sides of an equation by the same quantity. Division property, if A equals B and C is not 0, pretty important, then A divided by C is the same thing as B divided by C. But, we can't divide by 0, so that's why you have to throw in the C can't be 0. Substitution property is just if A is equal to B, then either A or B may be substituted for the other in any equation or inequality for that matter. Okay. All right, this one's going to seem silly. The reflexive property says that A equals A. Anything equals itself. The symmetric property says that if A equals B, then B equals A. Doesn't matter what side of the equal you're on. The transitive property says that if A equals B and B equals C, then A equals C. So if one thing equals the second thing, and that second thing equals a third thing, then the first thing has to equal the third thing. All right, so go back through those, pause the video. Make sure you've got the names down, like the difference between the reflexive property, the symmetric property, and the transitive property. All right. There's also properties of congruence. So there's a reflexive property of congruence, there's a symmetric property of congruence, there's a transitive property of congruence. Now remember, when we use the word congruent, we've got to be talking about shapes, not numbers. So that's why there is no addition, subtraction, multiplication, or division property. We add numbers, we subtract numbers, we divide by numbers. These are all shapes. So there's only the reflexive property, symmetric property, and transitive property. So the reflexive property would be, of congruence, would be if you say like AB, that segment is congruent to itself. or if we said that angle C is congruent to itself. Okay? The symmetric property would be like of congruence. So if segment AB is congruent to segment CD, then we also know that segment CD is congruent to segment AB. Or same thing with angles. If angle E is congruent to angle F, then angle F is congruent to angle E. And then transitive property of congruence is if segment AB is congruent to segment CD, and segment CD is congruent to some third segment EF, then that first segment AB is congruent to that last segment EF. Or we could do it with angles. If angle G is congruent to angle H, and angle H is congruent to angle J, then angle G is congruent to angle J. Those J's look weird. I don't like the looks of those. Let's fix that. J. That H is a little wonky too. Okay. All right, so again, stop real quick, make sure you've got the names down. Okay, once you feel like you have the names down, then on this next part, before you listen to me talk about it, stop the video. For these 12 problems, I want you to figure out if you know the reason why you can say what's said. All right, so I'm just assuming you stopped it, so I'm going to keep talking. So if x minus 5 is 12, why does x equal 17? Well, it's because we added 5 to both sides. So that's the addition property of equality. So basically, it's all the stuff that you've already known. It's just you're going to have to give a legitimate reason for why you're doing what you're doing. Besides just add 5 to both sides. Like there's a name for that. Is that it's the addition property of equality. I can add the same amount to both sides of an equation, and both sides of that equation, of that new equation, will still be equal. All right. Angle ABC is congruent to itself. So anytime something is either equal or congruent to itself, that's a reflexive property. So this is the reflexive property. And because they're angles, not numbers, it would be the reflexive property of congruence. All right, so if x plus y is 6 and y is 3, then x plus 3 is 6. So what they did, they took out the y and replaced it with a 3. That's substitution. And over here, remember, it didn't say of equality, it just said substitution property. So we're okay, just substitution property. Okay. All right, if t divided by 3 is 15, then we can multiply both sides times 3. And that way t would be 45. So this is the multiplication property. Of equality, because it's numbers. What we got next? If 2m plus 14 is k, then k is 2m plus 14. So all we did was change from one side of the equal to the other. That's the symmetric property. What in the world was I doing? I always print out my old notes just in case, I haven't taught this since 2020 was the last time I taught this lesson. So in case I have a brain fart, I just always am ready. I don't know what I was doing. I've got on my notes, I wrote division property equality. Like, no, we just turned this bad boy around. That is the symmetric property. If A is B, then B is A. What in the world was I thinking? Let me just double check. That is exactly the same as this. This is exactly the same as that. Yeah, I don't know what was, right here. Symmetric property. I don't know what I was doing. And nobody, I guess nobody ever went back and looked at my notes because nobody called me out on it. They're like, Sprint, why in the world would you think that's the division property? Okay. 2x plus 6y is 2 times the quantity x plus 3y. So that got distributed to become this. So this is the distributive property. BD equals BD. That's the reflexive property. It's the reflexive property of equality because it's an equal sign. Let's see what we got. So AB is congruent to MN. MN is congruent to RS. That means AB is also congruent to RS. That's the transitive property. It'd be of congruence because you got congruent symbols. All right, let's see what's happening next. If x plus 5 is 7, and then x plus 5 minus 4 is 7 minus 4. So they're just taking this equation. Okay, there it sits. And they're subtracting 4 from both sides. So that's going to be the subtraction property. Of equality. I don't know why I spelled out property when I didn't spell it out a single time on the rest of them. All right, if 10y is 20, then we're dividing both sides by 10. So y is 2. This is the division property of equality. If angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. So we're just turning it around. That's symmetric. Wait, is it 2? Oops, yeah. The symmetric property of congruence, because we've got congruent symbols. If A is B and B is 7, then A is 7. So if A is B, B is 7, then A is 7. That's transitive property. So there's a transitive property of equality. Now, you could also, this would be correct too, you could also say it's substitution. It all depends on how you look at it. So, because if you said that A is B, and then so where the B was, you plugged in A, then you could think of it as substituting. That would be fine too. Either one would be true. I guess more folks would say it was transitive property because they know what the transitive property is. All right, so justify each step used to solve the equation 3y plus 4 is 2y over 5 using properties of real numbers. So first, you're going to write the problem down. Okay, so every single proof you have, your first step is always going to be, oh, that was given. You got to have something that's given to you. Like, here's the problem. Now go do something. So that's going to be your first reason every single time. And this one, it says steps, but when we do geometry proofs, these are going to be statements. Now, we're doing it as steps right now because it's an algebra problem. But just know you're going to have, these are called 2-column proofs. So we're doing the algebra that you're familiar with, and it's going to lead us up to the geometry that you're not as familiar with. So here's our given. So what did they do first? To get from this first line to this second line, oh, look, they're multiplying both sides times 5, and they got to here. Because then the 5's would have canceled. So that's the multiplication property of equality. All right? From that step, how did they get from here to here? Oh, they distributed. That's the distributive property. All right, how did they get from here to here? They subtracted 2y off each side to end up with what's there. So this is the subtraction property of equality, because we're talking about numbers. How did they get from step 4 to step 5? They subtracted 20 off both sides. So this is, again, the subtraction property. And how did they get from there to there? They divided both sides by 13. So that's a division property of equality. Okay? So not only do you know how to solve it, you know how to back up with reasons why you said what you said. Okay, so there's 5 parts that make up a proof. There's going to be your given, which is the hypothesis. It's the if. Okay? You're going to have a prove or show that. It might say show that. That's going to be your conclusion. Or the then. Okay? You're going to have a diagram. No, I can't say no proof is good without a diagram, but for geometry proofs, we need a diagram. They don't make a lot of sense without the diagram. Now, other kinds of proofs, you won't have diagrams, like later on in, I'm trying to think if you'll have to prove anything in high school. Well, we'll prove stuff in calculus. So, yeah, there's going to be other proofs where it's just, like, you'll have paragraph proofs. I'll be honest with you, the 2-column proof sort of disappears after geometry. Most proofs after you get out of geometry just become paragraph proofs where you're just explaining. It's like writing an essay about why you did what you did. But when you're first learning proofs, a 2-column proof is a great way to learn them because every time you write something down, you have to back it up with a reason. So that's why in geometry, it's the logical place to learn how to prove things. And so to help with that logic, we do 2-column proofs. Okay, so we'll have diagrams every time. You're going to have statements, and you're going to have reasons. Okay? So there's certain reasons that you can give in a proof. So these are the 5 acceptable types of reasons. You can say, I know this because it was given. You can use any definition. You can use any property. You can use postulates, and you can use theorems that you have already proven. Okay, so here's our first example. So given segment RT and segment PQ intersect at S, so that RS is equal to PS and ST is equal to SQ. So that's what we're given. We have to prove that RT is congruent to PQ. Okay, so we're going to make ourselves 2 columns. We're going to have one column be our statements. The other column is going to be our reasons. And then we need a diagram to go along with this. So you've got segment RT. Okay, here's one segment. We want it to intersect segment PQ at point S. Okay, so we'll draw a segment PQ, intersect at S, so that R to S, okay, so this is congruent to P to S. Now, I'm not worried about so much the fact that it doesn't look like it, because I've marked it. It's so. And S to T is congruent to S to Q. All right, so we're going to start out with our statements. And if the same reason can be used for a statement, you can put it all into one step. So, like, here's all the things that I was told. I was told that segment RT and segment PQ intersect at S. I was told that RS is equal to PS. I was told that ST is equal to SQ. So all 3 of those things were given to me. Okay. Now, what am I going to do with this? And here's what we're trying to figure out. We're trying to figure out that R to T, this whole thing right here, is congruent to P to Q, this whole thing right here. So how am I going to get there? Well, I've got to introduce something that will get me all the way from R to T. So let's do this. I know that, let's say, P to S added to S to Q is the same thing as P to Q, that length. Also know that the length from R to S plus the length from S to T is the same as the length from R to T. And I know those because of the segment addition postulate. That's why I know that. So remember in those last notes, I was like, here's the ones you're going to have to know by name. You're going to use the segment addition postulate all year long. Okay? All right. So what can I do with that? Well, let's see. What if I take... Ooh, how about this? Okay, what if I take this one, and where PS is, I plug in RS, because it says up here that PS equals RS. And where SQ is, I plug in ST. So that would say that RS plus ST equals PQ. Okay, so I was taking this one, substituting these values into it, and getting that. Okay, so that was just a substitution. Substitution. There we go. And usually we just put substitution. So what can I do with that? So I'm trying, so I want RT congruent to PQ. So if I could show that RT, like the step before that, if I could show that RT equaled PQ, then I'd have it. So here's PQ, this is good. Oh, here we go. That sits right here, and it's the same as RT. So I'm just going to substitute RT in right there. And say there's another substitution. Now, you know what why can I not spell substitution? Substitution. Okay, remember what I said a while ago about how, like on the first one, it's like if you have the same reason, you can put it all in one step. Well, you can't, I know number 3 and number 4 both are the same reason substitution, but you are substituting on different steps of the work. So you can't throw that into one step. Like you have to, like, it all has to be laid out. And then from here, I could say that RT is congruent to PQ because that's the definition of congruent segments. This is the definition of congruency. If two segments have the same length right there, that means that they're congruent, or vice versa. If two segments are congruent, they have the same length. And you don't ever stop until whatever it was they said to prove is what sits right here. I mean, exactly that. Like, if we had to turn it around to get one thing back on the other side, then that'd be fine, but that would be a symmetric property. So, like, you don't ever stop until you end up with exactly where you're going. All right, so we're going to do another one. So this one, they drew the diagram for us. So I'm going to go ahead and just get my 2 columns ready. I'm going to have statements. And I'm going to have reasons. All right, so the measure of angle AOC is equal to the measure of angle BOD. And always mark your diagrams up. Okay, so AOC. So this angle right here is congruent to BOD's. So this angle right there. Okay. And we want to prove that angle 1 and angle 3 are congruent. So, oh, I forgot. This was my given. I marked it up. So whatever's given, you mark it up. Whatever you write down in here that you figure out, you mark it up. Because usually when you can look at what's happening, it really helps. So angle AOC is made up of angles 1 and 2. So let's do this. The measure of angle 1 added to the measure of angle 2. That's the measure of angle AOC. Okay. Also, the measure of angle 2 added to the measure of angle 3 is the measure of angle BOD. Because that's the angle addition postulate that we learned about before. And you can shortcut postulate like that. All right, let's see what we want to do then. So I'm going to take this and put it right here, because the measure angle AOC is equal to the measure angle 1 plus the measure angle 2. I'm going to take that and put it right there. So my next step is going to say the measure angle 1 plus the measure angle 2 is equal to the measure angle 2 added to the measure angle 3, because I just did a substitution. So I'm doing it every time. I want to put an I after that second T. I don't know why. All right, and then look at this. I've got this number on both sides. I'm going to subtract that off. That's going to leave me with the measure of angle 1 equals the measure of angle 3. Ooh. Okay. Now, I erase that on purpose, because here is what technically you're supposed to do. You're supposed to say this and say that's the reflexive property of equality. I leave that step out. Okay, here's why. Because these are numbers. I'm not talking about if it's a congruency thing, I put it in. But if it's just a number, I don't. Like 3x minus 7 equals 5x. So let's say minus 7. And my next step is 3x equals 5x. The reason I get to 3x equals 5x is because I'm adding 7 to both times. I don't think that I need to tell you that 7 equals 7 before I do that. Like, they're numbers. Okay? Measure angle 2, it's in the one diagram. It can only be the same number. Like, when it's a number, I think that this is optional. So, now, some people don't agree with me. Some people say you have to put that in there because it is not a constant. The measure angle 2 is not a constant. But in this particular problem, it kind of is. Like, there is only one measure of angle 2. Like, it's not going to change on you. It's not going to be 72 degrees one time and 5 degrees the next. Like, it's the measure of angle 2. I'm going to leave that out after this. Now, I said that. This was the first day we taught it. So, in my answers, in the solutions, I might leave it in. But it's one of those things where me and the other math teachers at Brebeuf, we had a disagreement about this. And I just had to let it go and not worry about the fact that they thought I was wrong, because I still don't think I'm wrong. Okay, so we're saying that both of those are the same thing. So I'm going to subtract that off each side. So the measure of angle 1 equals the measure of angle 3, because I did a subtraction property. Of equality. And then if I know two angles have the same measure, I know those two angles are congruent. Angle 1 is congruent to angle 3, because that is the definition of being congruent. So there's two things that are congruent: segments, well, for what we're talking right now, segments and angles. So the definition of congruent segments is that the segments have the same length. That makes them congruent segments. And remember, definitions are biconditional, so they work both ways. It can be like the segments are the same length, that means they're congruent segments, or the segments are congruent, that means they have the same length. Angles, same way. If two angles have the same measure, those angles are congruent, or vice versa. If those two angles are congruent, they have the same measure. Because again, biconditionals, if and only if. It works both ways. But yeah, that's what you do. And do I have that exactly here? I do. Nothing changed. So we're good. You're going to do these problems. So notice there's classroom exercises and written exercises. I've got all the answers right here. Okay. And I also have the solutions on Schoology. So if you want to look and see how I worked them out, go over there and look at that part too. But just try, don't have this in front of you as you're doing it, but check it one at a time though. So it's like, maybe I've got some Post-it notes on my desk. Let's see, I'm moving them right now so that they'll still be there. I hope I don't move them between now and then, because I'll forget. They're sitting over next to the cat cup. There's some yellow Post-it notes. Like, maybe get Post-it notes and cover up the answers and just move it down one at a time, because I don't want you to see the answer as you're doing the next one. That'd be silly. But I do want you to think about, I don't want you to wait until you're done and then you'll realize, oh, I did all these wrong. So I want you to check them as you go, but don't know what the answer is coming in. Does that make sense? I hope that makes sense.